disembodied calculations. Okay.
How was
It's
your weekend, Jeff?
11.6.
My weekend's really good. Except, one day I played, and the other day I worked. Oh, so got some play in there. Yeah, 11.6. Okay. So I kind of want to start with just a deep dive. We really haven't done a ton with factorial stuff yet, and we've done enough to kind of get through what we've seen. But we're going to see stuff like this now. Let me ask you this. Okay. Can you simplify that?
Yes.
Yeah.
Okay. Do it. Don't say anything. Go ahead and simplify that. Yummy. Now, as strange as the symbol and the definition of factorial is, have you ever seen a function like factorial before? Never. Right? Never have we seen a function that either has such a direct exclamation, like a direct a punctuation mark as a symbol, right? And its definition is so different from any other function we've ever considered. It is really different. So, can I just cancel the ends?
No.
Why not?
Is there addition, subtraction, and
Yeah, two things. They're part of an addition problem, but they're also inside of of a factorial. I was going to say inside of an explanation. Right? Same reason you can't kill the ends here. You can't kill the ends here, for sure. Okay, I like it. All right. So how do I do this?
You keep on writing terms till you get to n minus.
Yeah, which one of these am I going to break out?
The top one.
Because it's
Going down.
bigger.
Oh, yeah.
Right? So eventually, it's going to run in, it's going to become this guy. So I really want to make sure everybody understands how this works. N plus 2. So anything factorial is that thing times one less forever, right? So what's the next term? And then, and then, and then, and then, it would go forever, correct? So how would I write n minus 3 times 1 less forever?
Factorial.
Yeah, it's just the way. Okay. Oh no, look at it, he fell on his head. And now he's like a turtle. Oh, shit. Let's see if it works. Like a trooper. You guys understand that? Anybody, if you don't quite get it, it's okay. If everybody around just going like this, somebody's lying. Right? Does everybody understand what just happened?
Yeah.
Right? It's just like me saying 7 factorial is 7 times 6 times I'm tired. Right? It's true. It's not useful. Why is that useful? Because now what happens?
It cancels.
Yeah, this shit cancels. Right? I'm going to do something with that here in a minute. But that's just by itself something we're going to have to be able to do things like that. Right? What about this thing? Everybody understand what's happening here?
What is it saying on the bottom? Is that all in the exponent?
Yes. This is
Okay.
all up here. This is n to the this over n to the this. Try to simplify that.
Is distribution a step?
That's a great step to take first, but keep the rest to yourself.
Okay. I know how to do this.
Yeah. Look at that. That's so weird. You can't do both at the same time.
We're not.
Missing everybody. Yeah. Nope. There we go. Oh, there's that. Okay. I just did it. Yep.
Same page, man.
So I mean, basically the idea, how would you do this? How would you do? What would you do?
We would just subtract.
Now you
the
guys-
difference.
Okay, so if I
Oh, is it
simplify
easier?
this, what do I get down here? N to the 2n
Technically correct.
minus 6, yes?
Just more complicated.
Yes? Yes. So that's n to the 2n minus 4 minus 2n minus 6. Yeah, so 2n minus 4 minus 2n plus 6, right? And you can write it out for yourselves. 2n minus 4 minus 2n minus 6. So that becomes n to the second power, right?
Yes.
Second one.
I like my way.
What'd you do?
Like a geometric series.
You did what now?
So I pulled out n squared on the top.
Oh, I see,
canceled
okay.
out both.
Sure.
Yeah.
I love it. Crazy sauce. Okay, is everybody with me so far?
Same.
So don't forget,
Yeah.
factorials are new. So, but they're very straightforward, they're very single-minded, they're pretty straightforward, it's my hope. Still a little bit weird though, still new. This is old shit, any power shit, we know how it works. We know how every freaking power works, we know how they all freaking work. We just know, we've known it forever. I don't care what the base is, I don't care. When I'm dividing things that are like bases, I subtract the powers. What about if I'm doing series? That's the same damn thing, right? Okay, all right, so far so good? Okay. So, let me do a little bit more with this idea up here. Okay, let's see if I can make something that does what I want it to. Yeah, we'll find out. We'll do it live. All right. So I want to know. Let's see. All right, let me think. All right. Okay. Let me do this first. Yeah, and if I do this, okay.
Oh.
Okay, pretty good.
Oh.
There's a lot going on.
Yeah.
Yeah, there is.
What did you do?
Can we ignore it then?
Oh, wow.
Can you ignore it? Well,
Yeah.
I'll leave it in
it's
there.
only good.
but
I mean,
don't
right
touch
now,
it.
if you try to take a nap, see if I react to that, stare at a wall.
Have you had people sleeping in your class?
Oh, hell yeah. Depending on how I feel, I let them sleep or I had to instruct people to throw things at people who were sleeping.
Well, my old teacher used to do that to us.
Really?
Yeah, he would like, he had like a bunch of pens and like rubber balls to throw at people.
How good would the aim?
She was pretty good.
Yeah, so you know they had years of practice, yes.
So, since they're being multiplied, maybe factorial for the whole thing.
Oh, I see, you're kinda overthinking it. Pretend like that's not there for the moment. Would you do that the same way we did the earlier one?
Yeah.
Okay. Those two interact with each other because they're both factorials, so they both have parts that are eventually gonna cancel.
But the one on the left doesn't, it's not included because it's not
Yeah, he's
factorial.
not a factorial, he's just kinda sitting there. And he's not written in a form that it can incorporate. So real quick, because you asked the question, how can I rewrite this? Is there a way to rewrite that? You can do it. Yeah, it's n plus 1 factorial, right? That's just thinking about factorials backwards, right? So if I can break this up like this, I can bring that back in like that. Is this written in a way that it can be brought in? Nope.
Can you
Maybe.
explain that again?
Okay, so help me out. What's n plus 1 factorial?
N plus one.
Times n, and then you right?
Yeah, yeah.
Therefore, n plus 1 times n factorial is n plus 1
Oh,
factorial.
okay.
So I'm just bringing that guy in, right? So what is n plus 2 times n plus 1 factorial?
N plus one factorial, or N plus two factorial?
N plus 2 factorial. I like it. So as always, almost always is the case in math, it can go both ways, right? So be jealous. Okay, so what's happening with this guy? Which piece, if I just look at the factorials and why what about the problem with telling me to do that? Because they interact with each other. This guy can't do much of anything, so I'm just gonna forget about him for a minute. I'm gonna do what I can. If that wasn't there, I could certainly do something, so I'm just gonna do that thing and hope, right? So what do I do? Which one do I work with?
N+3.
The bottom, because it's bigger. So I can kind of break it out until it meets this guy, right? So I got this weird shit, this little tiny dude, and then this guy's got too much shit, let me break him up.
N+2, N+1, and N-1.
So those cancel. Why can you see this limit very quickly? You should be able to see this limit quickly.
It's 1.
It's 1. What's the bottom? Isn't the bottom end to the fourth plus shit?
Yeah.
Top's end to the fourth minus shit. So the degrees are the same, so it's the coefficient of the leading terms, which is 1. Do you guys see that?
Yeah.
Okay. Hopefully you're gonna think back to this moment and you go, oh good, thanks Jeff, because that weird shit's popping up in all my problems. Okay. So this factorial stuff is new. So I need to see how it interacts with other things. So the fact that I can pluck off so many, if part of it cancels, what's left becomes a polynomial to a defined degree. So therefore it could lead to limits I can do, right? Yes?
If the bottom didn't come out to be the same degree and was a different degree, what would we have?
If I would have put a 4 here,
Yeah.
wouldn't there have been one more term?
Yeah.
Then it would have been a 5th degree on the bottom, so what would the limit have been? 0. The bottom degree would be higher.
Alright.
If that would have been an n+2, one less term, top degree's higher, infinity. Yeah. So once the factorial stuff cancels, it just becomes ratio polynomials, easy, easy, right? Once these cancel, weird shit's gone, normal shit's back. Yay. That's another thing to notice. When weird shit cancels, forget about it. It's gone, right? But sometimes students get here and they're still kind of like confused because this thing was in the back of it. It's dead. It died. You know, you can say a little something. It was a good little thing. Never did me much harm, and now it's gone. And then you just do this. This is nice. Yeah, maybe. Okay. Let me see. There's one more thing I wanted to do, and now I can't remember what that was. Shoot. No. We're gonna do that one later. All right. We'll do that. Okay. Next thing. So we have more of this to do later. I just want to ask you what you think about this. If I'm given a series, and I want to know if it converges, but I'm going to give you one more piece of information. I'm going to tell you that I know, given, does this converge? Given that this converges. Does this information help me at all? So think about it for a moment.
Yeah.
Right? Why does it make sense that that would tell me if this converges? Why does that have necessarily mean that this converges?
Because even if it's a real number.
Sorry.
You go.
They could potentially be the same function, or if that one has negatives, it's more likely to converge.
Okay, at the worst, this is already all positive.
Yeah.
In which case these are the same, and that's actually not the worst, because then I just said it converged, right?
Yeah.
Or why is it converged even better, you know, whatever you want to say, to a smaller number? If these are not the same, then some of this must be negative. Maybe every single term is negative. And why is that still good? If the sum of the positive stuff is 7, the sum of the negative stuff would be -7, right?
Yeah.
Do you guys understand those are two extremes? Either this is all positive already, so that didn't really change it, or these are all negative, which means whatever this does also. Or some elements of this are negative and some are positive, which means it should be easier for it to converge then. I really want, right? That's why the alternating series test made sense. So remember, does this converge?
No.
No. Does this converge?
Yes.
Yes, because it meets all the conditions of the alternating series test, right? This didn't converge because it didn't get out of its own way, but this isn't always adding to itself. It starts off something and then it's subtracting, and then it's adding and subtracting, and it's adding and subtracting, so it never lets itself get too big. Maybe? Okay. So it seems to be that if the sum of the absolute value converges, this definitely converges. No question. So watch this. This is kind of silly. What do you think we would call this kind of convergence?
Absolute convergence.
Holy shit. Right? Math people were very creative. We said, it's convergent, we put absolute value. It's called the absolute convergence. Okay. So kind of is nice. It goes, that's nothing wrong with that. It's not that bad. Right? So this is, if this is true, then it's absolutely convergent, which just makes it sound like, are you convergent? Absolutely. But it's absolutely, meaning, with the absolute values, convergent. So what about this? Is this absolutely convergent, this here?
No.
Is that absolutely convergent? No.
Conditionally convergent.
Yeah, it's only convergent if you don't take that -1 away, right? If I take that -1 away, is it convergent now? No. So there is a condition for it to be convergent, just don't take the absolute value of it. So is this convergent? Yes.
Yeah.
We actually proved that. I think it's one of the first things we did for AST. But it only converges if you don't do the absolute value. So it's not absolutely convergent. This series is conditionally convergent. There's a Y in there. There we go.
And alternating series are like an exception to the rule, I guess.
No, what do you mean?
Like, that would,
All right, let me do a couple things.
is absolute convergence a rule, or is it just something that
No,
only
in
sometimes
order,
applies?
so in order for a series, given a series to be absolutely convergent, this must converge. Are you with me? Given any sequence anywhere, alternating, whatever. So I'm given this sequence, it's alternating.
But this isn't a test.
No, it's
Okay.
just an idea.
Okay.
How would I accomplish seeing what converges or not? I would apply a test, right? So this isn't a test. We are going to do some new tests. These are just two definitions. And we haven't taken the absolute value of a given series before, just willy-nilly. We sort of talked about these two, right? So what's new? These are just definitions. If you take the absolute value and it converges, does that mean, yeah, the question mark. If you take the absolute value and it converges, it's absolutely convergent. What about this? Is this convergent?
Yes.
Yes, in fact, it's absolutely convergent, meaning it converges if you take the absolute value or not. It is absolutely convergent, right? So what's a good example of this? What about this guy?
That's absolute.
To check for absolute convergence, what series would I look at?
1 square.
Because what's the absolute value of this? The -1 component would go away. So are we cool with that? If this is AN, this is the absolute value of AN. Why does this converge? P series, greater than 1. I love P is 2, right? So what would we say about this series? This series is absolutely convergent. I love it. The beautiful thing is, if I have a problem that says see if these are conditionally convergent or absolutely convergent. And I get this problem, am I gonna do the alternating series test?
No. You're gonna take the absolute value.
Because I already know it would be P series. Once I got this, I'm done. I really want this to make sense. If the problem said, all right, given these series, is it absolutely convergent or conditionally convergent, right? You with me? That's what the problem's gonna say. If I can show it's absolutely convergent, I'm done. Because it automatically converges if I left it alone. I don't have to do the alternating series test. You can actually do that. If I give you this problem and I say, does this converge? You can say, well, since this converges, then that converges. You don't have to do the alternating series test. Isn't that quicker? Alternating series test has the three things you gotta show. This, P is 2 greater than 1. I'm done, right? So if I can show that the absolute value of what I'm given, that series converges, I know what I was given converges. Because why is this even better? Because some of the elements are negative. So it starts off positive, then it subtracts, and then it adds, and subtracts, and adds. It can never get to infinity then. That's an automatic thing, okay, if this is convergent. Okay, maybe. Now, what if you do this? What if you take the absolute value and it doesn't work? Then you come back and do what with this?
The alternating
Alternating series test, yeah. To see if it's conditionally convergent. Okay, maybe. Yes.
So the only like options conditionally convergent and absolutely convergent.
Or it's just divergent.
Oh, or divergent,
I mean,
yeah,
yeah.
exactly. Doesn't have to be convergent, yeah.
Yeah, but for convergence.
Yeah, so it could be divergent, it could be conditionally convergent, it could be absolutely convergent. So let me ask you sort of a silly question. You have a question about this?
Yeah.
Go
So just to clarify then, if we know that the absolute value of A of n converges, then A of n converges?
Yes.
Okay.
Please does that make sense to everybody? If I have a series and I make all the terms positive and that converges, and then I go back to making every other term negative, well, that's gonna like definitely converge, right? Does it make sense? Because in the second case, it's kind of taking away from itself and then adding to it, and then taking away and then adding. It's never gonna go to infinity then. Okay. Maybe. So, is this series absolutely convergent or conditionally convergent?
Absolutely convergent.
Why is that kind of a silly? Well, maybe it's not
Because
that
they're
silly.
always positive,
Do
no
this.
matter what. Why did the 10 have any?
Well, the
because
10, if it's n equals 1.
then it was problem.
Oh,
So I really want you to understand, the idea of absolute convergence doesn't give a shit that the original function was all positive, correct? When I take the absolute value, does the function actually change at all?
No.
Considering I'm going from 1 to infinity, no, right? You guys understand? Isn't it already all positive terms?
Yeah.
So, and why is this convergent, period?
It's imitating 1 over n squared.
I'm trying to be 1 over n squared, so you could do a direct comparison, or you could do a limit comparison, right? But we're getting to the point where we're like, that's just freaking 1 over n squared, leave me alone, Jeff, right?
Please.
We're getting to that point. Notice how I say the word getting. So yeah, you can do all that stuff, this will be convergent, but it is absolutely convergent because if I took the absolute value, it actually is the same series, right? I really want that to make sense. Okay, so conditional convergence means if you take the absolute value, it diverges, but if you don't, it converges. That's conditional convergence. So is this conditionally convergent? No. If I take the absolute value, it's the same series because they're already all positive. Yes.
Does that basically mean only alternating series can be conditionally convergent?
Yes.
Okay.
Yes. And I gotta be a little careful. It doesn't have to be alternating in terms of every other term. Just some of the elements
Right.
have to be negative
It
and
has
some
to
have to
go
be positive.
positive.
Like infinite number of elements negative and an infinite number of terms positive, that could be conditionally convergent. So it doesn't have to be every other one. Yeah. I like it.
And there are alternating series that are absolutely convergent, right?
Of course, yeah, we just saw, like this one.
Yeah.
Yeah. Okay.
So that would just be 1 over n squared.
Yeah, exactly. So if we take the absolute value of that, it's 1 over n squared sum, P series. So it's absolutely convergent. Do I have to do any AST then? No, it's absolutely convergent. It converges no matter what if I leave it alone or if I take the absolute value, it's good. I like it. Okay. And by the way, just to show you, let's see, just to show you something. No.
It's divergent, or it's conditional.
Yeah. Okay.
That's
just 1 over n.
Is that alternating?
No.
Not technically. But is it sometimes positive, sometimes negative?
Yeah.
Yes, but doesn't it take a while for it to become negative?
Yeah.
Right? At first it's cosine pi over 12. Then it's cosine pi over 6. Then it's cosine pi over whatever the shit. Pi over 4, pi over 3, pi over, right? And eventually it's going to become negative, and then eventually it's going to become positive. Are you guys with me? Just to show you, I really want to make sure you understand. There are series that have infinite negatives, infinite positives that aren't positive, negative, right? I don't need to put -1 to be something to have a series that is sometimes negative, sometimes positive. You guys sort of with me?
For the top one, is it possible that you can do like limit comparison on that, and then take out like just have the positive like the 1 over n squared?
Why would you?
If you leave this in, you do alternating series.
Yeah.
If you do the absolute value, it's a P series. Now, could you ignore that it's a P series and do direct comparison or limit comparison? Of course,
Yeah. Okay.
right? Okay, maybe. We proved P series from interval test, right? But now that we know, so, all right, I'm gonna just leave it there. Okay. That would actually be kind of weird because what would you use? Real quick, what would you use to compare that to?
1 over n squared.
Yeah, 1 over n squared.
Okay, but do you see how you have to know what 1 over n squared does in the process of trying to figure out what a 1 over n squared does?
Yeah.
Okay. All right. So just really get a feel for, so absolute and conditional convergence added nothing to our list of how to check things. Are you guys with me? It just added some definitions. Yes?
So with that bottom equation,
This
is
is
that
crazy.
absolute?
Yeah, this one, okay, this is just a quick example. Can you guys understand this is a little bit weird? Now the major thing is, isn't the top a constant basically for every year? Is the top going to infinity?
No.
No.
The highest is.
So what would you think this is doing?
1 over n.
In fact, can somebody please tell me, what would be the best test to use?
Direct.
Say it again. Direct comparison, not limit comparison. Because what is this?
It's 1 over n cubed.
Less
Oh, 1
than-
over n cubed is greater than cosine pi n over 12.
Yes, exactly.
So yeah.
So this is less than that. This converges, therefore this converges.
Bing bang.
Okay, bam, bam, boom. Yeah. So anytime you see a bounded function, and what's the most common bounded function? Sine and cosine, right? If you see a bounded function, it's screaming for direct comparison. Yes.
If we were to do absolute convergence, though, if we were to just put absolute value bars in front of that, that would still.
Yeah, if I put absolute value, this still is true, correct?
Yeah.
Yeah. So that works. So there are situations where it's a little weirder in terms of absolute value. What does it actually do? Yeah, so I mean, I want you to realize the functions we're analyzing, every single function we've analyzed so far is relatively nice. I mean, it's nice. Could these get exceptionally, quickly. Are there functions you guys that don't even know exist? Oh yeah.
Show us
Show
a
us,
crazy
show us.
symbol that doesn't make any sense.
Huh?
Or like
Show
a
us
weird
something.
symbol.
The whole function.
That's not
That's
real.
not
That's
real.
hangman.
Anybody know? It's hangman. Does anyone know what that is?
Isn't that used when
That
you're
looks like
taking-
Hebrew.
Do you know what this is in mathematics?
Isn't that used when you're like converting a factorial into a function?
No. Yes. This is what's
I
called
just
a
watched a YouTube video on it, so that's why.
gamma function.
Oh, okay, that's.
I
Yeah,
saw
you use a
Simon
gamma
this
function
time
to
today
convert
and
a
it blew my
factorial
mind.
into
Gamma
a
function.
continuous function.
There's something that you guys, I think you learned this in Calc 1, Bessel functions?
No.
No? Maybe it's here.
Bessel?
Oh, this is coming up later this semester, I think.
No.
Bessel functions.
Vassal or vessel?
Vessel.
Vessel. Okay.
Bessel.
Can you write us a function that we have no clue what it is?
So again?
Can you write us a function that we have
No,
clue
let's not do that.
It's Halloween. It'll be
Alright.
really scary.
You should have that like pop
Right,
quiz.
right. Yes.
Stop.
Okay. I answered you. Yes, I could. Right, you get it. Okay. I'm not going to. So, the very first idea in 11.6 is that. That's it. The idea of absolute convergence versus conditional convergence, right? Pretty straightforward idea. Yeah? So basically, you could look at any function we've done so far that's alternating and think about whether or not it's absolutely convergent. So I'm just adding, it's just another definition. So if I made it always positive, would it still converge? If it does, absolutely convergent. If it doesn't, maybe conditionally convergent. Okay, maybe. So that's not a new test. So let's talk about a new test.
Oh.
Okay. Remember, let me see.
This is 11.7.
11.6 still. 11.6 has got 3 things in it.
What's the name of this factor?
Absolute convergence and ratio and root test.
See how it's 3 things. Okay. Yeah. Remember this guy?
Yeah.
Wasn't he a beast?
Yes.
Okay.
It was not very cute.
So it wasn't that terrible. Once you see the idea of what to do with it, sure. But I could very easily make something that looks like that that's much worse than that. Well, yeah, it's gonna happen. Thankfully, we're gonna develop a method that will make it much easier to analyze such things, right?
Okay.
So, this method is so freaking cool. So let me ask you this: if I had a, all right, let me start one by one. So if I have this series here, can anyone just tell me if this converges and why?
Yes.
Why?
Because it's
Bottom is
3.
The bottom is always greater, or is gonna always be greater than the top.
Say it one more time.
The bottom, like, growth is outpacing the growth of the top, it's like.
So
always
it
bigger.
goes to 0. That doesn't tell me if it converges or diverges. I'm sorry. Let me be careful. I meant for this to be. In my head, this was this. Okay. Not just a sequence. If it's a sequence, you're right. It's just going to land to 0. Does that converge?
It may.
We don't know.
Come on, you know. Come on, you know. How do they get from here to here? And does that hold? How do you check if it holds? How do I check if it holds? If I do 27/64 divided by 9/16, what do I get? 27/64 times 16 over 9. You get 3/4. Is that cool? And if I do that with any elements in there, it's going to be that, because the ... means the pattern I see continues forever. And this is the pattern I see. Multiply by 3/4. Now, real quick side note, there could be multiple patterns. So I try to give you enough so it could only be one pattern. Okay. Little
It's
side note.
it's P series.
No,
Oh, it's
it's
geometric.
Geometric.
I always fix them up. Yeah. it's
Geometric is when I keep multiplying by the same thing over and over.
Yeah.
So is this series geometric?
Yeah.
Oh.
Is this geometric?
Yes.
Yes. Is it convergent geometric?
No.
Why?
Because it's 5 to the n minus.
R
1.
is
Greater than 1.
R is 5, which is bigger than 1. So whenever you have a geometric, tell me what R is.
3/4.
Don't just say R greater than 1. Because you could just be like a 50-50 chance. R. So I want to know that you know what R is. Okay. Okay, that's not that bad, right? Okay. Can you imagine? All right. So how would I check to see if something's geometric if I'm not immediately seeing it is? If I have some weird function that's a1, a2, a3, and I can't tell it's geometric, how would I check to see if it's geometric? What would I check?
Divide one of the terms by the other.
Yeah, give me an example ratio you would make.
Like A4 divided by A3.
A4 divided by A3.
A3
And you would
divided
compare
by
that to
A3 divided by
A3 divided by A2, 11, right? So aren't you doing AN plus 1 divided by AN, yes? And that, any one you choose has to come out to be the same number for it to be geometric, correct? Now, let's expand on this a little bit. What if I'm not perfectly multiplying by 3/4 every time? Right? What if I'm multiplying by something, let me see, how do I say this? What if I'm multiplying by something that itself is going towards 3/4? So, let's see, I'm gonna try to do something on the fly with you guys that I've never done before, so let's see what happens. It just came to mind. This could be really exciting. Exciting meaning an absolute train wreck. Let's see what happens. Okay. Oh shit, let's see. 1 plus, let's see, I want to make something that's not too crazy. What if, okay, so what if I'm adding, what if I'm multiplying, let's just make the sequence elements, and then we'll add them, correct? Is that cool? So what if I'm multiplying by, first I multiply by 1 plus 3/4, right? And then I take that, right, so that'll be, or 7/4, is that cool? Right, okay. Mm-hmm. And then I multiply that by 1/2 plus 3/4. And then I multiply that by whatever times 1/4 plus 3/4. The thing I'm multiplying by, okay, I really want this to make sense. So let's see, do you see how what's happening to the thing I'm multiplying by? 1 plus 3/4, 1/2 plus 3/4, 1/4 plus 3/4. The thing that I'm multiplying by is approaching what? 3/4. So in the limit, if I let this go forever, eventually I'm basically going to be multiplied by 3/4, aren't I? Eventually this just becomes a geometric, or close enough to it, right? So it should have the same rule about converging. If this approaches a number less than 1, it should converge. Maybe. So let me see. That was weird. I gotta work on it. I've got to workshop that with myself. So, if I am given a sequence and I take the limit as n goes to infinity of the next term divided by the previous term, I'm going to do absolute value. Because remember, geometric is the absolute value bar, less than 1. So this covers me in case there's any negative weirdness happening, right? I really want this to make sense. If this is less than 1, then this series converges. Because at some point, what I'm multiplying, let me see, watch. So let's say this equals some constant, right? Let's just say it equals some number. That means eventually my next sequence element, I get it by multiplying the previous one by C. Right? I really want you guys to see that. All I did was multiply that up, correct? Okay, you guys gotta be with me. So if the limit of the ratio of these two is C, that means eventually, somewhere, if I go far enough out to get the next element, I'm basically multiplying by C to get it. If you guys are with me.
Does that mean it turns into like a geometric series after that, or?
Yes. Is it ever perfectly a geometric series? No. Because does it ever actually reach this? No. But it's getting infinitely close to that. I really want this to make sense. So, if something divided by something else is a number, that means that this something is a multiple of that guy, correct? If the limit of this is a constant, that means that at some point, far out in my sequence, the next sequence element is roughly this times this. How close to this will it be? Really freaking close. Because if the limit is c, don't I have to get infinitely close to this? Okay, maybe, yes?
I forgot what I was gonna ask.
Now, that very first, I should have left that up here. How did I create that very first sequence I had up here? 1 plus, how did I make the next thing? I just multiplied this by 3/4, right? And then I multiplied by 3/4 again, right? Okay. So what I'm saying is, and this is interesting, maybe someday I'll actually try this. This is this thing I was kind of messing with. If I multiply by something that's changing, but it's approaching 3/4, that means that eventually it's going to become basically geometric. That means that this element is this times that, roughly, right? So I want this to make sense. Let me see what you guys think about this. What if I had something where I multiplied by 3/4 and then I multiplied by, by 1, and then I multiply by 3/4. Oh, this would be an interesting question. And then I multiply by 1. That would be evil. Okay, that's a little too evil.
2 of them, right?
It's a little too evil. Yeah.
2 series, one of
But
them
it
is
still
odd.
converge.
They
So the way you're looking is perfect.
They both have to converge.
And so do you see how this is a sequence in itself? Every other one is its own sequence?
Yeah.
Is it convergent?
Yeah.
Yes.
Yeah.
Do you see how this is a sequence in itself?
Yeah.
Is it convergent?
Yes.
So is the whole sequence convergent?
Yeah.
Yes.
Yes. It's the sum of two finite numbers. Okay. So, if this is true, and this is less than 1, then eventually this becomes geometric, where C acts like R. Because how do I create a geometric sequence? How do I get the next sequence element? Don't I multiply the one before it by R? Isn't that basically what this is saying? So if the limit of a ratio is a number, that means that somewhere in the long term, this becomes this times this. That's the only way the ratio could be C, could approach C. So, what does this mean? What does all this mean?
So if you got like far enough, like you started using really big numbers and plugging it in, could you kind of approximate where it can?
Yes, yeah. And that's what I want to do with that first thing I was doing. I want to I got to kind of write it out for you guys. It just came to mind. I've never tried that before. I want to see what that leads to. So yeah, if I do like what I was doing first, but I need to get it written down for you guys. I was trying to do it on the fly, but it's a little more involved. You could tease out what that R value would be. Yes, or what's approximating R. Okay, so let me ask you guys. We've seen this kind of thing before. Let me think. Yeah. If the limit of something is 0, what does that mean about the elements in the sequence?
They converge.
Sure, yes.
You're getting smaller.
How small can I make this? How small can they get?
Infinitely close.
Infinitely small, correct? Yes. What if it equaled 1?
They're getting infinitely close to
That
1.
means at some point, the elements get infinitely close to 1 and stay at least that close. At some point, that must be true, yes? So would you agree that if the limit of some series, some sequence is 1, I can go far enough out and eventually I basically get this. Yeah. Maybe it's 1.87 trillion, 87 trillion zeros, 1. Are you with me? Which to most humans would be 1, right? 1.87 trillion zeros, 1. I would call that 1. Yes, right? Okay, so that's what this means. So if the limit of this ratio is some constant, that means eventually this is that constant times the one before it, which is exactly what a geometric is. I really want to make sure that you understand. Believe it or not, we're going to call this the ratio test, right? This is called the ratio test. So if the limit of this to this is less than 1, then the series converges. You with me? If it's greater than 1, what does it do? Diverge. If it equals 1, that's where things suck. It's inconclusive. We have to use some other test, right? So let's try this. Let me write what I just said, and then we'll do an example.
This feels
So-
pretty similar to testing alternating series.
No.
No?
Sorry. So if the limit of this is less than 1, then an convergent. If the limit of this is greater than 1, divergent. If it equals 1, inconclusive, and that really sucks, because that means you have to go back and use direct comparison, limit comparison, some other kind of integral test even.
Are you passing out a worksheet for this?
Say again?
Are you passing out a worksheet for this?
Next time. Yeah. Today I'm just happy I got the grade sheets printed out. I have actually this is on the thing I gave you
Yeah, it's
already.
on this one.
Yeah,
Oh, no.
yeah. Good catch, Jeff. Okay, so let's do this series.
That's Jeff.
Which way was it?
Teacher Jeff.
I don't like that now.
What is that?
Let's apply the ratio test to this series. So what is an? This is a silly question. What's an?
And
N to the N over N.
N to the n over n factorial. What is an plus 1?
and
Not a very silly question.
N plus 1 to the N plus 1.
Good.
Over N plus 1 factorial.
So let's set this up. To set this up, it would be the limit. No, not gonna work. Limit, n goes to infinity. Oh, really? This guy divided by, so this is gonna happen all the time almost, so times the reciprocal, right? You've seen that before. Divided by, so times the reciprocal of this. Do you already see some stuff you could do to simplify this?
the factorial.
Yes! Go ahead, mess with that factorial, kill some shit. Do it. It'll feel good.
Killing things feels good.
Sure, kids, this is not life lessons, by the way. Only do this with mathematical expressions, because they have no feelings.
They deserve to die.
Or I'm gonna find out later that everything you canceled in your whole life, Jeff, felt that. I'm like, oh, no. Oh, crap.
You've killed a lot
It's
of
even
numbers.
worse than somebody telling me how many ants I've killed in my life. I'm like, every variable you messed with felt that. Oh, man. Alright, let me catch up to you guys. Alright, everybody's gonna squeak. So some really neat things happen.
That's so squeaky.
So of course you can rewrite this as,
N plus 1 times n factorial.
yeah, n factorial, you can do it, Jeff. And this will be n to the n. So these cancel. Does anyone else see something that happens immediately? How many n plus 1s are on the top?
N plus 1s. There's N plus 1, N plus 1.
There's n plus 1, n plus 1s. How many can I lose? How many?
Just one.
I can kill one of them, right? Doesn't one of these n plus 1s cancel?
Yeah, it's just N plus 1 to the N.
Yeah. So let's see what we got now. We got the limit. N goes to infinity. I love it. Of n plus 1 over n to the n. Yes.
Why did we multiply by the n factorial over n to the n?
Where are we at? Sorry.
Uh,
Oh, this.
Yeah.
Okay. What's this say? So what's an plus 1? Isn't that this? Then I'm supposed to divide by, so I'm going to multiply by the reciprocal, right?
Oh,
So I multiply by the reciprocal of this, because I'm supposed to divide by it, but I'm just gonna jump. We've done that kind of thing before, yeah. Okay. So that's gonna happen very often with this thing. Okay. So a lot of our series are ratios.
Sorry, it's a stupid question, but when it's n to the n plus one to the n plus one, how can we get cancel out the n plus one and the n plus one on the bottom?
Wait,
I was gonna
so you're
ask.
talking about this thing that happened
Yeah.
here?
Yeah.
Okay, so let's look at that by itself. So n plus one to the n plus one, what does that mean by itself?
It grows.
No. Like 7 to the 8th, what does that mean?
Power.
True, but what does it mean? What does the 8 mean?
Oh, it's 7 times 7 times 7.
Okay, I got 8 sevens, right? I got 8 sevens. So how many n plus 1s do I have? N plus 1, n plus 1. Right? So if I divide by 7, what is that? 7 to the 7, right? Because I lose a 7, correct? So if I divide this by n plus 1, don't I lose an n plus 1?
Dude, that's so cool.
I had this many of them.
Oh, you're not getting rid of the n plus 1, you're just getting rid of plus 1.
Yeah.
Yeah.
Oh, it looked like you were canceling out the whole
So remember,
thing.
what is
I was
this?
messing
What is
up on
2
that.
to the n plus 1? Can't I write that as 2 to the n
That makes sense.
times
2 to the 1.
2 to the 1, right?
Yeah.
So if you want to, this is n plus 1 to the n times n plus 1, yes? So then, die.
Something died.
Okay, maybe. This is maybe not the best example to start with, it's kind of gross. But too bad. We did. Now, what can you do with this? Here.
You can break it apart into
Whoa.
2 fractions.
Sort of. Yeah, inside you could. In fact, I don't know if you guys even remember what this is the definition of. So if you break it down inside, doesn't it become
1 to the n plus 1 over n.
no,
to the n.
careful, no, you can't go that far. You can't distribute this power. Do you guys see that? What's n divided by n? 1. What's 1 divided by n?
1 over n.
Okay, so isn't that the same thing? Does anyone remember what this is the definition of? Yes! This is the definition, I'm sorry. Yes. I'm sorry, I got really excited. I don't know if you guys even, does anyone else remember that?
The definition of what?
This is the definition of E. This is E.
The whole limit.
Is?
Yes. This is one place where E comes from. To me, it's the more boring place E comes from, but. How would you show that if you didn't know?
I don't. Take the natural log.
Okay, cool. So I'm trying to investigate this thing. Oh man, this is so much good shit.
I don't know 1 is 0.
So I take the natural log, right?
Yeah.
Then I'm trying to do the limit, right? So whatever I get the limit of this, I'm gonna have to raise e to it to get what y does. Yes, do you remember this? Like logarithmic differentiation? No, well shoot. What sucks about trying to investigate this limit is that n is up in the power, right? What form is this in? As n goes to infinity, what does this do?
0.
It goes to 0. So this is 1 to the infinity. Does everybody understand that that's not 1 necessarily, and that's not infinity necessarily? Why is it not 1? Because isn't 1 times 1 times 1 1?
Yeah.
So why is it not 1? Does this ever become 1?
No, it's
No.
always multiplied.
So it's never 1. So it's always something bigger than 1 to a big ass power. So it might not be 1. Why is it not necessarily infinity? Because if this goes to 1 quicker than this goes to infinity, then it will be 1. If they go about the same speed, it's going to be some number in the middle. I love you guys. Are you guys doing okay? This is actually
Not after that
Quantum
sentence.
this is a quick review.
I was doing
In
it
fact,
till
this is
then.
how limits work. Why is the limit as n goes to infinity of 3n squared plus 2 over 2n squared minus plus 7? Sure. Why is that 3n's?
Because if you divide top and bottom by the highest
Sure,
power.
you can say it like that. What's a better way to say it? What's a more conceptual? What's the concept behind it? They are both growing at the same rate. Yes? But this is growing at the same rate, but it's always 3 times n squared. This is always 2 times n squared. So that's why they kind of break even at 3/2. If I make this cube, this is growing at a much quicker rate. It overtakes the top. goes to 0, right? So, if this goes to 1 faster than this goes to infinity, then it's going to be like around 1. If this goes to infinity faster than this goes to 1, then it could be infinity or some big numbers, right? Okay, so. I love this. This is a perfect time for this review, because this is going to happen, and this is a review. I'm trying to investigate this function, correct? What sucks is this stupid thing is up in the power. It's difficult to kind of work with, right? So let me do one thing. I'm going to change everything over to x's, because eventually I'm going to have to use L'Hopital's, because this is indeterminate form, right? Okay, this will be the last thing we do today. Don't get too excited.
Ever.
That's the last thing you will do ever.
That's intimidating.
So if I take the natural log of both sides, I can then investigate what this does. So if I do the limit and I get 2, that's what natural log of y does. So what does y do?
Nothing.
Goes to e squared. If the natural log of y goes to 2, then y goes to e squared, right? Yes? What's the base on natural log? E to the second power is y. There you go.
Yeah.
So that's the trade-off. If you take a natural log to make it easier to work with, the last thing you have to do is undo what you did. You have to raise e to it to undo the ln you did. Okay. Can I use L'Hopital's in this?
Yes. No, there's no.
There's
To
no,
bring it, the x,
there's no-
1 over x.
There's
on
no
the bottom.
ratio.
good, there's no ratio. So then I'm forced to. You could either put the ln on the bottom and make it 1 over ln. I highly recommend you don't do that. I'd rather take the x, put it on the bottom as 1 over x.
And then you swap back up.
Does everybody see what just happened?
Oh wait. Oh, I see.
Yes. Yeah.
I know there are students who maybe remember this and go, I never understood that first place, I don't know what. But multiplying by something is the same thing as dividing by its reciprocal. Or dividing by something is the same thing as multiplying by its reciprocal, right? We know this. So these are the same. This looks worse, but why is it actually better? Because now it is a ratio, and L'Hopital's is built on limits of ratios. What form is it in? As x goes to infinity, what does this go to?
0.
0. Good. That goes to 0. Natural log of 1 is 0. As x goes to infinity, what does this go to?
0.
Ah, remember that?
That's-
Okay. So let's do L'Hopital's. How do we do L'Hopital's on this?
1 over 1 plus x equal.
Times.
No,
no.
times.
Yes.
1
plus-
plus 1 over x.
1 over x times.
Negative
1
Right,
minus.
good old
X
chain
to
rule.
the negative 2.
1 minus 1 over x squared. No.
Negative.
1 derivative is 0.
Minus 1 over x squared.
Yes.
Yeah.
There we go.
And what's the derivative of 1 over x?
Minus 1 over x squared.
Yeah,
They
There we
cancel.
go.
these cancel. And what do I get when I let x go to infinity?
0, so 1.
0. So I get 1. That's what natural log of y does.
So e it.
So y goes to e.
That's
Okay.
so
What does that mean?
It's divergent.
Yeah, because e is greater than 1, correct? So that's divergent. Where'd it go? My original thing is gone. I erased
Down there.
So it was n factorial over that, right? Okay.
Oh, it's the other way around.
It was the other way around? Oh, yeah. Shoot, I lost it. I knew the other
That
way.
equals 1. Wait.
What's up? So the result of this, what the bit equals e, Jeff? Oh yeah, that's true. This limit is e. That's greater than 1. Therefore, this series diverges. Because what does this need to be for the series to converge?
Less
It
than.
needs to be less than 1. What rule is that similar to? The rule for geometric. Why is it similar to that? Because it's the same idea as geometric. The limit of the ratio is a constant. That means that constant eventually is acting like a multiplier, just like a geometric. And what has to be true about a multiplier of a series that makes the terms, what has to be true about that multiplier for it to be convergent, less than 1. That's why the ratio test, that's why the test makes sense. It has to be less than 1, just like geometric series, for the exact same reason. Oh, you guys love this, yes?
So then is that another definition for E? Like for the M?
Yeah, this is actually one of the most fundamental definitions of E.
The other one, the N to the N over N.
Yeah, the limit of Zinger's infinity of this thing. Yeah. You see this in finances when you do compound interest, continuously compounding, which is why I hate it, because I hate anything involving business. I much prefer the definition of E being, if I start at 1 for y equal 1 over x, how far do I go until this area is 1? I go up to the E. I like that much better. E is the number that I start at 1, I go up to it to make this area 1. I much prefer that. That's the better definition of E to me. Okay, anyway. Okay. So, that was a semi-rough one to start with.
Yeah.
But still, I wanted to do it because it was kind of gross. So you've got that on, remember, you've got that old sheet that actually goes through 11.7. That sheet I gave you a while back with all the tests on it. It's got ratio tests, it's got root tests, what we're going to do next. It's got absolute convergence, all that kind of shit on it. Yeah. All right. So coming up if you got questions, otherwise I will see you.
You already got the 2 missing points on my test, right?
Say again?
You already got the 2 missing points.
2 missing points.